Hello students, this is Ms. Mason here. We are in lesson number 3, Geology lesson number 3. We talked about plate tectonics being the large-scale movement of plates on the surface of the earth. So remember, the crust and that outer mantle make up the lithosphere, and that lithosphere is divided into these large plates. So there's 7 main large plates. The Pacific plate is actually the largest. And I talked about the San Andreas Fault, how that's a boundary between that Pacific plate and the North American plate. So this whole theory of plate tectonics is a theory in geology that explains how continents have formed. And since these continents are part of plates, and the plates move, the continents move. So that the plate tectonics theory supports continental drift. The fact that continents drifted apart. Originally they were part of Pangaea. They drifted apart into the position they are today. And plates are still moving. Remember, I talked about going about 10 centimeters a year, and that is the rate at which your fingernails grow. So same rate that your fingernails grow, the plates are actually moving. So even though you don't think the earth is moving below your feet, it actually is. And that is plate tectonics. So today we're doing lesson 3, Geology lesson 3. We're going to talk about some boundaries between the plates. So where the plates interact. Talked about yesterday that transform boundary in the San Andreas Fault. The plates slide past each other. All right, the North American plate is actually going south, and Pacific plate is going north, and eventually, in about 16 million years, the scientists estimate that LA will be north of San Francisco, since LA is attached to the Pacific plate, and San Francisco is attached to the North American plate. So the transform. Hello students, this is Ms. Mason here. We are in lesson number 3, Geology lesson number 3. We talked about plate tectonics being the large-scale movement of plates on the surface of the earth. So remember, the crust and that outer mantle make up the lithosphere, and that lithosphere is divided into these large plates. So there's 7 main large plates. The Pacific plate is actually the largest. And I talked about the San Andreas Fault, how that's a boundary between that Pacific plate and the North American plate. So this whole theory of plate tectonics is a theory in geology that explains how continents have formed. And since these continents are part of plates, and the plates move, the continents move. So that the plate tectonics theory supports continental drift. The fact that continents drifted apart. Originally they were part of Pangaea. They drifted apart into the position they are today. And plates are still moving. Remember, I talked about going about 10 centimeters a year, and that is the rate at which your fingernails grow. So same rate that your fingernails grow, the plates are actually moving. So even though you don't think the earth is moving below your feet, it actually is. And that is plate tectonics. So today we're doing lesson 3, Geology lesson 3. We're going to talk about some boundaries between the plates. So where the plates interact. Talked about yesterday that transform boundary in the San Andreas Fault. The plates slide past each other. All right, the North American plate is actually going south, and Pacific plate is going north, and eventually, in about 16 million years, the scientists estimate that LA will be north of San Francisco, since LA is attached to the Pacific plate, and San Francisco is attached to the North American plate. So the transform slide, that is one of the boundaries. That is one of the boundaries of plates. All right, so that is the first plate boundary. Where this happens, where that transform boundary is, there's a lot of seismic activity, such as earthquakes and volcanoes. This is why we have a lot of earthquakes in California. All right. Next, so that is the first boundary of plates. That is transform boundary. Second boundary, where plates come together, or just they're interacting. The second one is converging. So converge, think of C, starts with a C, connect. Or if you want to say colliding. They come together. All right, so where they come together, it can lead to formation of oceanic trenches or also mountains. All right, Mount Everest is formed by the Eurasia plate and Indian plate, and they're still coming together. So actually Mount Everest is growing by a centimeter a year because those plates are still converging. So converge, think of the mountains, Himalayas, Mount Everest, converge. Mount Everest, converge, transform. Remember the transform slide. So like this is our transform slide creating earthquakes. All right, converge, come together, connect, starts with a C. Converge starts with a C, connect starts with a C. Forms mountains and other things. We'll talk about the oceanic trenches later. That's the second one. Number 3, the third type of plate boundary, big plate boundaries, are divergent. Diverge, separate, divide, right? Diverge, going this way. So diverge, 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 divergent, divide. Plates are moving away. Plates move away. So the mid-Atlantic ridge between Africa and South America is a divergent boundary. So some plates go away from each other. Some come together and some slide next to each other. All right, so question number 1. Stop and think. Number 1, you're going to explain transform boundaries. So what is a transform boundary? That's question number 1. Stop and think. Welcome back. Question number 2. Stop and think. Question number 2. What happens at a convergent boundary? So explain just what happens at convergent boundary. That's question number 2. Stop and think. Welcome back. Question number 3. Stop and think. Number 3. Divergent boundaries. You're going to tell me about what happens in a divergent boundary. Divergent. That is number 3. All right. So we talked about the 3 boundaries, and you're going to tell me about them. All right. I'm going to go right on number 4. Number 4. Stop and think. Talked a lot about the San Andreas Fault. I want you to tell me what type of boundary that is. And also, what do we experience as a result of that type of boundary? So what does it cause? So right now, San Andreas Fault, what type of boundary? What are the effects of that? That is number 4. Stop and think. All right, so we reviewed, we went over 3 types of boundaries between plates. So where they interact, They create a boundary. All right, so they can either transform, slide, that can cause shaking, the earthquake, or it can converge and form mountains, and also oceanic trenches. Think of Himalayas. Converge, come together. Diverge, dive. Think of like you're diving in. Dive, divide, going away. All right, Mid-Atlantic Ridge in the Atlantic, the ocean floor, the Atlantic, between Africa and South America. There's a ridge. It's divergent. So those are the three types. Number 5, I want you to tell me, give me 2 results of these boundaries. 2 things that can happen, any type of boundary. So I want you, like any type, if it's divergent, convergent, transform, what are 2 effects of that boundary? So give me the name of the boundary, 2 things it can cause. That's number 5. Stop and think. Okay, welcome back. The next thing, I want you to go into Google Earth, and you are supposed to just practice the navigation, experiment with it a little, but I want you to, this time I want you to actually really look at the continents and how their conformation or their shape would indicate continental drift. So I want you to think about how the shape of the continents is evidence that continental drift actually happened. Okay? Then there are going to be some questions I'm going to post that ask you to study plate boundaries and plate tectonics using Google Earth. So there'll be some directions how to use the Google Earth that will guide you along with that. So it's an excellent website to check it out. It's similar to Google Maps. If you've ever used the satellite view on Google Maps, it's a lot like that, but it's a large scale. So you see it's like a virtual tour of planet Earth. You get to see all the landforms of it. And I want you also to notice the locations of mountain ranges and trenches. And then think about the plates, the lines, or the borders, the boundaries between those plates are located. So, number 6. Number 6, stop, think. This one's a little review here, but I want you to think about what landforms might we see at these plate boundaries. So if you were to go on Google Earth right now and look at some areas where 2 plates, or there's plate boundaries. So the area where the Eurasian plate maybe connects to the Indian plate, or where it interacts, interacts. And then what landforms would we see there? So I want you to think about boundaries of plates. What type of landforms would we see? That is number 6. All right. Next thing I do want to talk about a little is the fact that these plates are moving. Right? The Earth is moving all the time. Continents have moved over millions of years. Right? And the evidence we have is not just the shape of the continents, but also they've done studies using seismic activity, looking at refraction, the waves, how they, oh man, stop. So now we're going to talk about looking at Google Earth. What you are observing is really the topography of planet Earth. So topography means the study of the features of the land's surface. All right? So when you were looking at the continents, mountain ranges, valleys, things like that, you're looking at the topography. So the words topography means the study of the features of the land, surface of the land, so the continents. All right? You are also looking at bathymetry. So bathymetry is underwater topography. So bathymetry, when we talk about bathymetry, we're talking about like oceanic trenches. There's actually mountain ranges and trenches under the water in the ocean, on the ocean floor. So it's basically the same thing as topography, only it's under the water. So the two words you should know: topography, study of the features of the land surface, and bathymetry, underwater topography. All right, so number 7, stop and think. Number seven, I want you to tell me the difference between topography and bathymetry. So topography and bathymetry, I want you to tell me the difference. Okay, that is number 7. Number 8. I want you to tell me the similarities. So the first one is the difference. Number 8, similar. What's similar between topography and bathymetry? That is number 8. All right, number 9, we're going up. Okay, number 9, stop and think. Now this, number 9 and 10, extend beyond the video lessons. You have to do a little research. Number 9, the question is, I want you to look up Pacific Rim of Fire and give me a 1-sentence description of what it is. So basically tell me the Pacific Rim of Fire. All right, number 10 then, stop and think. Stop, think. Last one, I want you to tell me 1-sentence, describe a tsunami. So what is a tsunami? And I'm also going to post a video on TED-Ed for you to learn a little about tsunamis, so that'll help you. So number 9, I'm going to get Pacific Rim of Fire, and number 10, tell me what a tsunami is. And make sure you submit on Google Classroom with complete sentences. They start with a capitalized letter in the first word of the sentence and they end with a punctuation mark. You guys rock on. I love you. Rock stars. Find your inner nature nerd.